Good evening all, and welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We're really excited to bring you Assessing the Solutions with the TI-nspire with Melissa Horrigan and Ray Cross. My name is John Bayman, and I am your host at this event. I teach mathematics to years 7 to 12 students at O'Loughlin Catholic College, Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And tonight I'm excited to introduce our first panelist, Miss Melissa Horrigan. Good evening, Melissa.
Good evening, John. Thank you.
There you go. I was telling you about not having the mute button on. It was me that ended up doing that instead. So there you go. Made everyone else look great.
I was one in every group, hey?
Thank you. That's swiftly moving on. So as you can see, Melissa certainly walks the talk when it comes to using TI technology, having followed the development from using the TI-82 through today's TI-84 CE, and currently uses the TI-nspire along with the TI Navigator system in her classroom. This gives Melissa a deep knowledge of the use of technology and first-hand experience of applying this and maximizing her students' learning. Melissa is also keen on investigating ways to apply the flipped classroom pedagogy in her classroom. Melissa, thank you for being with us this evening.
Looking forward to having fun with this webinar.
Great. And our second panelist for this evening is Mr. Ray Cross. Evening, Ray.
Evening, John. Evening, all.
Ray has a vast experience in teaching mathematics, curriculum resources, and sharing his knowledge at national and international conferences. Ray is passionate about the use of TI technology to enhance mathematics teaching, learning, understanding, and enriched thinking skills. So Ray, thank you as well for joining us this evening. Ray, I'll pass over to you if that's okay.
Fine, that's good. Thanks, John. Tonight what we're going to have a look at is basically how TI-nspire has and the numeric CX can explore, understand, learn, and assess mathematics. Essentially, they're the topics that we're going to be looking at. Mel and I will go through those, and as well we're going to, in particular, towards the end, Mel's going to focus on the navigator system and how that can be used to assess both individual and class learning. So hopefully a bit of Euler will help us to oil the mathematics machine in your classroom. Couldn't help myself there, John, but anyway. So just to kick it off, firstly looking at the TI-nspire CAS system, are you aware of the fact that the Navigator and CAS system has a logic functionality, and one of the things that we can use that for is to look at both the commutative and the distributive law. So looking at A plus B plus A, obviously if we enter that it will show true. If we enter A times B equals B times A, it will show true. You can look at the distributive law, then if we just swap those two terms around, both will show to be true. You can actually define a variable as a matrix or a column vector, and you can see I've done that there. How you do that, for those of you that may not know, is let's say we might try to define H. Just put H control template, and that defines. Then if we go to the template again, you can see if it were to be a column vector or matrix, we can just insert whatever numbers we like in there. So that's how we've defined those various matrices or vectors. Now you can use that to enable some sort of exploration, understanding of matrix operations, in that up here, since we've defined those, if you press bar, you can see we've already got the three variables that we defined, U, V and W, and we can look at U and we can multiply that by V, and interestingly enough what happens is it's not going to work, and obviously it's not going to work because we've got a mix match in the with respect to matrices. However, in terms of rows and columns, however, if you press U and then we multiply that by W, you can see it comes up with that interesting result. Now, getting students to explore this rather than learning the rules is obviously pretty important, so if we change that around and look at W and multiply that by V, you can see it comes up with that sort of result. If we looked at W and we multiplied that by U, you can see you get that sort of result there. So it's really interesting to get students to explore this sort of thing, see if they can develop for themselves some sort of understanding of the pattern that's working with that. You can do the same sort of thing with the vector dot product. In other words, we could have a dot product of, for instance, U and V, and see what that gives us. And then if we had a dot product of don't want that, do we? But if we had a dot product of V and U, instead of U and V, it'll come up to be the same thing, and you can investigate that and discuss that at class level. Whereas if you tried a cross product, so we'll have a look at perhaps that one. So we'll go to, let's get out of there, we'll go to matrix and vectors again, come down to cross product, and if we looked at cross product of U and V, you get that sort of result. Whereas if we had a cross product, I won't do it because of time, of V and U, you get a different result. So obviously by exploring these sorts of things and discussing it with your class, you can develop the relationships for cross product, DOS product, and so on and so forth. So all that's pretty interesting, and that's the thing that we want to try to clarify or illustrate, is the fact that the calculator can be used for exploration and understanding rather than just using it for pressing buttons and coming up with an answer. If you go to the CX, for those of you that got CX, the numeric calculator, obviously if we put in A plus B equals B plus A, it's not going to say it's true because A and B are undefined in the initial stage. You've got to put in numbers, or if you put in a variable, it has to be defined. So if you do 1 plus 2 equals 2 plus 1, it's true, and then these various entry lines there, you can see some matrix calculations, a dot product. Then if you define A and B in the way in which we did previously, A dot B doesn't work. We would obviously want to discuss that, and dot A times B will work, and cross P will work because of the fact that you have defined those particular variables. So obviously that's something that you might find to be of some particular use. The other thing that's I find useful and not given very much attention is just swapping back to the CAS calculator, is the way in which the CAS calculator operates with units, constants, and you can do a little bit of dimensional analysis. So here's a little file here that I've made up previously, and basically what it tells you is it means that you can actually, for those of you who may not know, you can actually insert a unit and you can do operations within it. The way you access that is by pressing the catalogue, and number 3 gives you a list of constants, and you can see here that's the speed of light. You've got this little chevron down there which tells you what it is: Coulomb constant, acceleration due to gravity, universal gravitation constant, and so on and so forth. So underneath that, various constants for length, for area, or various units rather, for volume, and so on and so forth. So that's very useful, and you can do some pretty interesting sort of things with that. The way in which you can get the underscore, of course, is by pressing Control underscore or Control space on the keyboard, and then if you just press C, that tells you that it's approximately 3 by 10 to the power 8 meters per second, and that's obviously the value for the speed of light. So you can go through and put all those sorts of things in there, some examples in there. Also, it enables you to do some conversions, and the conversion operator can be found again within the catalogue. Go to the top, and there it is. Or You can also access the conversion operator just by pressing Control, catalog, and you'll see it's listed there in that template. Now what you can do with that, we can see here on the next page, is you can convert. So say for instance we wanted to convert from kilogram to gram, just go to here, look at so it's probably better to press there, 52.2 kilogram into the operator, press enter there. Now you want to convert that maybe into something else, just say gram to make it easy, into that, and it tells you it's 52,200 grams. So you can do that sort of thing, which is pretty useful. Temperature conversion is another direct proportionality, so it has its own little function built in, and you can access that under the temperature menu. You can do some divisions like so between them, so that tells you the ratios involved, and you can compare units by dividing one by another. And what you can do with that is you can go through and look at that there are 2.47 acre to the hectare, and if we just grab this point here and just graph that, you can see you can change this thing here. And if we had a look at, as I had occasion to do in the last fortnight, a property worth 12.4 hectare, do a little conversion, that's about 30.6 acre. So you can use it in that way, and you can do a little dimensional analysis, so you can see pretty useful. Metre per second multiplied per second metre. If you want to look at this one here, obviously Newton's law, kilogram multiplied by acceleration converts into units, but does that sort of thing for you. And then also over here, the TI-4 plus CE has kilopascals. For some reason or other, that unit is not listed in the CAS file, but what I've done here is just build out a little program, and that's stored in the library, and you can actually just convert in that way. So you can do your own little program which will allow you to do conversions. Now basically with the CX version that's not available, but I understand that operating system 4.5 will be out in the next couple of months, and that's going to have full unit functionality. So that's something for you to keep in mind if you have a numeric CX calculator. Now I've got a couple of little files that no doubt will be available, I guess John, tomorrow or in a day or two we'll have on the website, and one is a little activity unit conversions which you might be interested in doing. You can use that on the CX or you can use it on the CAS, and there's all instructions there. That's quite a useful little document. And the other one is from a TI whiz kid in Portugal called Nelson Souza. Now what Nelson's done is he's built up a file which enables you to store it within your library, and it does conversions. So just some examples of some conversions, and again you have to have a separate little function for a temperature conversion. So if you want to look at some conversions on the CX, you just can download that, and we'll have that available for you on the website as within a day or two, and that would be obviously pretty useful over the next few weeks. So that's stuff that's that's quite often neglected, but I think is a fairly useful little activity. If you go to VAR, you can see that you can access those things. The help file is a pretty interesting one, and that lists all the various units that he's got in there. Now, pretty clearly, one of the things that I've found over the years is that students don't really understand very well the concept of inverse function. And so looking at the CAS calculator, you can use that in quite an interactive and dynamic way to be able to help you to understand the concept of inverse using a few different modes. Algebraically, if we just put in solve y equals 2x plus 1 to x, it gives you that answer. And then if we swap the x and y, you could actually do this as a little exercise and solve that for y, it gives you this, which is really interesting. You can get the students to discuss that. We put y equals mx plus c, solve that with respect to x, it gives you this. So clearly, after a bit of discussion, if we swapped x and y and solve, you get inverses, and these two functions are inverses of each other. It can be further explained graphically. So within a graph, we can enter a function. So let's have a look at the function that we've got here and just perhaps edit that. And we'll just change this in here to be equal to x and press that in. So there's the function. I'm sure you've done this sort of thing before, but it's a good idea to get students to do it and they can get an understanding, a much better understanding of what's going on, hopefully then learn it. And we've just got a couple of sliders that we put in there. For those of you that might not know, how do you enter a slider? Just go to Menu, Actions, and down here insert a slider, and then you just name the slider and you can do various things here, including minimise it and so on and so forth, so we won't enter that. So that's how we've got A and B in there. Now, how do you get this in? How do you get the relation in? Well, there's a couple of ways. One of the ways is by pressing Menu, Graph Entry Edit, and there's relation. And you can enter them there. You just put y equals a function, x equals a function of y. So basically, you're just, as we said, reversing the x and y. So the function with x and y being swapped. And then it graphs. And just by changing these values of A and B, and a little bit of discussion, students should get an idea, and this is the y equals x, you can get a bit of an idea of exactly what the relationship is graphically between a function and its inverse. You can represent this with a spreadsheet. So here's a sequence which is generated pretty simply. Then we've got an exponential, then log of that, and so if you take the inverse of the function, then it gets you back to where it started. So there's a good example of what's going on with respect to that. If we go to the CX, the numeric calculator, and look at inverse with respect to that, because it's numeric, you only do a numerical solve, and if we put y equals 2x plus 1 in with respect to x, obviously it's obviously going to work because you've got a couple of variables that can only do it in one variable. So I just want to show you a couple of other things. We've got a function in here, x squared, we've restricted it. We've got a domain restriction from -2 to 2. And then we've got a couple of other relations in. Now, the other way in which we can enter a relation is you can take a function just in the function menu, and you can just back-click, remove the 0, it gives you all these possibilities, less than or equal to, less than equals, greater than or equal to, or relation. So if we want to have relation 3, so we want to have something like say x squared plus y cubed maybe equals x times y, and that's what. So what we've got to do there is put 3, we'll tab out of that and put equals, and maybe just do x times y very quickly, enter that. Then you can see black that that's been entered. So let's just delete that one. and we'll hide that. Now the other way in which you can enter a relation is, I've just got a text there, and if you just enter a text on the page, I just might just delete that. Now how do you enter that? Menu, actions, come down here to text, so just click on page, put x equals, say y squared, enter that, and if you just grab that and move it up to either of the axes, that's the other way in which you can enter a relation. You can restrict y and x, both of them, if you enter it like that, and if you enter it in this format, you can only restrict y. However, in the new operating system 4.5, I understand that with this mode of entry, you can restrict both in the same way, and you'll also be able to do that on the CX. So
the other, Ray, the other way you can also enter your relations in too is by going to the menu button.
yeah.
Yes, and choosing number 3, your graph entry edit.
Yeah.
And when that comes up, you've got relation in there as well.
Yeah, I did that one before, I think, didn't I? Yeah.
Oh, you just went in using the backspace part. But yes, that produces the same entry line from before.
Yeah, it does. But I did in the previous CX CAS one. I think I did that, Mel. So
My apologies, I missed that.
Yeah, I think I did. Hopefully I did. I might not have. Anyway, that's. I'll just keep moving then because thanks for that, Mel. But yeah, there's those two ways, and then the other way is by just inserting text and dragging it up to an axis. That's obviously going to work fairly well. So just moving on then from the exponential and log functions, one of the examples of that is compound interest, and I've got a couple of little files that I've made up here which hopefully will help. I've found over the years that that's something that's not really well understood. So in this example we've got P, the principal, just set down here with a little slider as 1, and we've got the compound interest formula here. X is the number of years, and obviously I've got X here with this vertical line set as 1, and it's running along the X, the horizontal axis. Now if we increase the number of payments per year, and the interest rate is obviously 5%, you can see that initially you have quite an increase, a jump in the early stages for payment increase, an increase in the amount at the end of 1 year. But later on, as you increase going up to maybe 365 rest, it's not increasing by much at all. So you have the major sort of increasing occurring initially. If we graph it like this, so you now look at this function graph where X is the number of payments per year, you can see that as the number of payments per year increases, approaches infinity, then we're approaching a limit. And that limit is 1.05126, which is actually e to the 0.05, the interest rate of 5 over 5%, 5 over 100. You can represent that more correctly, I guess, if you use a discrete analysis. Put in a list and spreadsheet sequence. It's got those values there. Nothing particularly smart there, just 2 to the n. And then here we're looking at the amount of money that we get at the end of the year if you've got the number of payments per year being 1 or 2 or 4 or 8 or whatever. Now, just doing a data sheet, data and stats sheet, you can see that this more correctly represents what's happening as you increase the number of payments per year. When we go into looking at on the CAS calculator, you can use this functionality. That doesn't exist on the CX. If we go to the CX, you can see that that's blanked out. So you can't do that on the CX. But on the CAS, you can look at that. We all know that, of course. Might not be aware of that. As you change the 1 to an A, it becomes in the limit e to the A. So you can do that. And then we can also use the functionality of the Tvm Solver to look at the effective rate of 5% if the number of rests is equal to infinity, so that effectively becomes 5.127, and the nominated rate can be calculated if the effective rate is 5.127 within the number of rests. That comes out to be 5%. Do it on the CX by doing it this way, and here's just a little bit of maths that I've just put in as a comment very quickly. If we've got this sort of thing for the growth rate or growth factor, you can change it around to be the formula for future rate is equal to that, and then just using the concept of inverse, e to the ln of r, and then just to make it a little bit simpler and not confuse the making a little product of r times years, just put the years in the front, it ends up being that. Probably another way of doing this is by using the Tvm Solver and just inserting that. So if you went to your catalogue, and you can see you've got TVM functionality there. That's the number of payments, the interest rate, whether you what the initial payment was, which was $1, that's a negative one, which is something to remember. The future value, how many payments per year, and whether you've got payment at the end or the beginning, defaults at the end. If you insert that function like that, you can see that as we increase the number of years, as we increase the payment per year, if you looked very carefully, if we just go up here a little bit further, if we look at what's happening here, you can see as we change the payment per year, this goes up quite a bit initially and then slows down. Looking at it as a discrete function, putting in a sequence like so, and putting in a future value like that, and then doing a data stats page. We've got 1 year, payment per year, so it goes like that. We change the number of years, we just have to look at doing a data zoom, like so.
And you can see, Ray, how those sliders can make the visual so dynamic as well.
That's right. Well, I'm just using, this is just locking onto that and just using the scroll functionality of the cursor, or if you just press on here and just leave it there if you're using a handheld, it does the same sort of thing, which I only really discovered that yesterday. I wanted to do that. Haven't done it before. So just do it like that. And I think that illustrates it very nicely. And you can see, as you're doing that, how it is approaching a curve, and obviously the curve is a exponential. So Mel's done some work on exponential and functions recently, and she's got some data on it. So John, I think we might hand over to Mel, and she can take it from here and look at how you can analyse individual students and class results on this topic and others.
That'd be great, Ray. And I think it's really nice as well. Thanks for actually being able to show us both the CAS computer algebra system calculator, as long as just the CX without the CAS. And that was really nice to sort of see the similarities between the two, but also the subtle differences as well, and what the extra things that the CAS calculator can do.
Yeah, it's obviously an advantage to be able to do that, and as long as it doesn't become too confusing, that's the main problem.
Yeah, that was great. So thank you. And Melissa, I can see your computer screen nice and clear, so all yours. Thank you very much indeed.
Thank you very much, and thank you, Ray. And as Ray said, I've been doing some work. My Year 11 Maths B students are working on exponentials and logs at the moment. And fitting in with our Euler, explore, understand, learn, and assess, I like to use the Navigator system to be able to assess my students just formatively and diagnostically at regular intervals to see just how much they have picked up. What I have up on the screen at the moment is just a small document that I put together that asks the students a few questions. So what they've done is last week in the lesson we had very quickly reviewed most of our exponential laws, and they'd had a couple of lessons where we hadn't been working on that. We'd been finishing off an assignment they were doing. And so on Monday, yesterday, very start of the lesson, I gave them this document here, which has just got 5 questions in it, as you can see shown up on the screen here. They were just seeing how much they did remember. And what I like about using the Navigator system is the fact that I can send this document out to the students wirelessly, and they write in their answers to the questions. So it's just going through, just checking their understanding of how, what an exponential means, so what power tell us to do, situation with a negative exponent, basic multiplication with the same base, what happens when we've got a fractional exponent there, and then finally ask them to simplify. Now I thought these were pretty basic because these students had completed this work last year in grade 10. They'd done, as I said, a quick review last week on it. And so I then get the information back from them, and when I draw the information back, I am getting the information and saving it into my portfolio. So the portfolio here is a way to gather information from the students on how they went. And if I have a look at the results on that particular set of questions, you will see that I have students that got 1 out of 5, 2 out of 5, and that was my highest result. So obviously I need to have a look at what was going on there. Sorry, opened up the wrong part. And so what I'm able to do, and I actually did this with the students, is to look at what sort of responses they gave me. So what I was looking for here is an answer of 16, but also for them, as it said, show mathematically how you calculated this, is for them to show me that it's 2 times 2 times 2 times 2. So I had some show me that. I've had some work in pieces, working their way up, etc., so that wasn't too bad. But then when we started to work in, well, what does it mean when it's got a negative power there? I had some that have given me answers, some that have shown me, well, okay, I think they understand the idea behind the negative does mean it's a fraction, but then I obviously need to help this student because they're not understanding that we then remove the negative as such. Here, what I'm obviously hoping for is where they're adding the powers together, and they're all able to show me that, so at least I know that we're going okay with that one. This one was a bit of a test one to see how they went, and if they understood the idea that your fractional power could also then be written using your surd symbol. And as I've said in the question, do not solve, and so I've got students that have solved it for me. So that does tell me, and as I said to them, they're not reading the questions, they're not reading the information, and that's one thing that I think we all notice when we're going through a marking exam. the students that have not read the full question and are not answering it. So what I like about Navigator and being able to do these style of question documents is I can get that information from the students just in class. Took about 10 minutes, 15 minutes, depends how slow they're working, and I'm able to look and, I guess, diagnose, so diagnostics in a way, what do I need to focus on next. So that's something that I did with the exponentials. Continuing to have a look at what our focus is tonight, the next thing that I am looking at is quadratic functions. Now, with quadratic functions, something that we have done recently is to investigate with regards to, sorry, I've got the wrong documents open here, to investigate about the features and how our graph changes depending on our values of A, B, and C. So another thing that I like to do with my students, and it works whether you've got the CX or the CX-CAS, or like the CAS or the non-CAS calculators, is to get them to investigate, so that explore, to be able to develop their own understanding rather than here's a rule, now let's just use it. So this document here was one that Ray has done up, and what I like about this, and I focused just on this first part of this one with my students because we'd actually just finished the unit on quadratics, but is to look at what does the A, the B, and the C do with respect to how the graph, how it affects the actual graph. And when you're using sliders, you're able to see very easily and talk to the students, and they investigate, well, what does happen as I change my value of A? And what happens when that value becomes negative? So by even just giving them a document like this, or having them do the document up for themselves from scratch, which is very easy. I'll show you just, it's a matter of adding a page in, adding graphs, and what we are able to do is, depending on the version, you need to be upgraded to the latest versions operating systems, and it is something that we do have to remind our students to do, but we can actually put in there A times by X, and it's going to ask us, now, because A is already defined in this document on the previous page, it's automatically put a value in there. Okay, what I can do, I'll change that. Instead of it being A, I'll call it W, because W is not defined there. And it says, do you want to create a slider? And so what I'm going to do is say yes, and it automatically puts the slider on the page for me. And what I'm able to do is go and change that slider. So by right-clicking with my mouse, because I am in the software, I can go into settings, and it's the variable that it's linked with, the value that it starts at, minimum value, maximum value, and how you want it to step up or increase. So then, all the students need to do is to drag along, and that's very powerful, seeing, okay, what does happen with that W? So what, in this particular case, linear, but what's it doing? So very easy to do, but you do need to be on the latest of last couple of operating systems. So I think that came in, the automatic sliders came in from about 4.3, 4.2, and we are currently running at 4.4. So they can investigate back here with our quadratics, increasing the B value, seeing what that does, and so on with the C. Now the other thing that I like that John has put on, that Ray put on this page is over the side here, the B squared minus 4AC. And I was saying to my students, I asked them some questions. So while they had this document in front of them and they were investigating, so they're going through exactly as I've just been doing, and I sent them what is called a quick poll. So if we go back to my portfolio there, I have quick poll instructions or information. And so what a quick poll is where you send out a question just during the lesson. So it's not a pre-prepared document, and you can even send it out, just ask the question verbally, so you leave this question part blank, but I typed it in. The quick poll in the navigator comes up the top there. It looks like a polling box. So when you click on that, it says, what type of question do you want? So I've typed in the question, what does the discriminant tell us? So the students had that document in front of them. They had the page open. They were investigating. I hadn't said any more than that. What does the discriminant tell us? Now, again, this is something we had discussed only about 2 weeks ago. And so I was happy when some of them went, okay, if the discriminant results in a negative number, the square root cannot be found. For quadratics, it means there's no x-intercept. But then I've also got one down here, I can't remember. So that does tell me I need to go back and review that. And what I do also like is that, and I don't do this in front of most of my classes, unless I know the students really well, but if I run my mouse over it, it tells me which student didn't know that answer, so who I need to go and work with. I then said, well, when the discriminant's negative, this means. Now, please excuse my spelling of discriminant there because I was typing quickly and just want the students to answer. So some of the students you saw answered at the beginning in the first question, and so we're able to look at what does it mean. Okay, and they've started to pick it up a little bit by the conversation. Then I asked them, what is the value of the discriminant when the graph just touches the x-axis? And what I liked about this question is, one, it's again looking at, are they paying attention to the question that's been asked, or have they formed their own question in their mind in a way? Because what I was looking for here is the value of the discriminant. And when the graph just touches the x-axis, they should know that we've only got one solution. Okay? And so, but what the value of the discriminant is it's actually 0. And so what I was looking for here was 0. But I did have a student that said 1. And so what they've mixed up is they've answered for me how many solutions are there when it just touches the x-axis. But by doing the quick polls, I was able to find that information out. And as I said, when you're in a document, doing the quick poll is a matter of clicking on quick poll, choose the question type, click insert, and type the question. So type the question there, and when you're ready to go, once the question is typed, then you are able to go start poll. Now, in this case, it's not showing up as available, but that is because I haven't actually begun my class. I don't have a Navigator class attached to this. Now, that same document can be run in our CX calculators. Okay, it can be run the same way as I just had it, which I have some students in my class that have CX. I have some students in my class that have the CAS calculators, and I tend to run with just the CX software, CX Navigator, and I have no problems communicating with both lots at the same time. In this one here, again, we've got the quadratic set up there. You can adjust the value and you're able to see how that's changing. And you can also set it up as a relation, and you can look at b squared minus 4ac. So what does it give us when a is 0, b is 2, c is 2, etc. And you can also use things such as the polynomial roots of that. Okay, and it's finding that information. So what we're able to see there, we've got positive value for our discriminant, okay, and we can look at the values with that. So the idea behind it is that the students are actually investigating for themselves. It led to some class discussions. I was able to link with lessons about, we just finished doing transformations, and then of course the learning part is when we're doing the actual teaching, and I was able to assess them. So through that one document I was able to get all of that information. So that was a quadratic function one. Now these have been basically what we've talked about so far have been Year 10, Year 11 Maths B, Year 12, but the next thing I want to look at is how I use this as well with a Year 8 class, because I do like to bring the calculators into my younger level classes. And the geometry in this one, we're looking at volumes at the moment. We've just been looking at volumes, and I wanted to talk to them about what is a prism and how do we define a prism. So what I did for that is I found a document that was actually already on the TI website. Love going to the TI website, either the American or the Australian, and looking up activities, because there is a plethora of them out there, and it saves me having to do them. And when I went in there, I found this prisms, it's actually called slides, but I changed it to prisms and pyramids. And so what I was able to do with this class is, again, I sent it out, and the students had this on their calculators, and it was to look at identifying the cross-section and how our prisms and our pyramids are different. Now, because I found this activity on the website, what also comes with it is a nice document which you can either give to the students as it is, which provides them with full instructions, but I just gave my class the second page of the document, and I said, well, okay, we're going to have a look at these prisms. We are going to slice them horizontally, and they had to make predictions. So getting them to think about, well, if I slice this horizontally, what shapes am I going to get if I slice it at the bottom, if I slice it in the middle, if I slice it near the top? And so I got them to make the predictions first. Then we went in and I let them play with it. So it's a matter of grabbing the circle there and taking it up. And we can see there with this one that we get the same shape, same size all the way up. So they did that for the rectangular prism, they did the triangular prism, they did the cylinder, and then we got to the square pyramid. And what they should see here is, yes, we start with a square, but what we do notice is it does get smaller and smaller. So with a pyramid, because it's coming to the point at the top, we don't have that consistent or regular cross-section. And so they investigated that by predicting. They sketched the actual as we went through it, and then they wrote down what changes, what stays the same. So that led us again to the discussions afterwards, looking both at horizontal cuts. Just move my horizontal out of the way. There we go. So I was then doing the vertical cuts, which is from front to back. Okay, what's happening there? And it led us to some really good class discussions in terms of what is a prism, how do we define it, and then from there we're able to look at how do we find the volume for our prisms. And I found that the Year 8s, that worked really well with them, rather than just telling them this is a cross-section, now we find the volume by finding the area of the cross-section and multiplying by the height. So they're doing this explore and understand. The last one where I do use a lot in terms of the document is using sine, cosine rules, and also unit circles. And there are some amazing documents out there. I know that I am running low on time, but just very quickly, this one here, the sine rule. So as it says, to grab and drag any of the vertices. So in this one here, a geometry page has been set up that has the triangle there. It leads us, you can talk to the students and remind the students about labelling their vertices or their angles with the capitals, their sides with the lowercase, and down the bottom are the links there. So what happens is the students grab any of the points and they can change this around, see what happens as they move point A, and what they should start to see is that this value here, which is the ratio between your side of A and your angle, your side of C and the angle, etc., so A over sine A, B over sine B, and C over sine C, that we actually have the same value. It's consistent. They can also then go in a little bit further and look at it in a different way. This one has just got the measurements and angles up in the triangle, but what they're seeing is those ratios there, and again, by clicking on it, they can see what they have as A over sine A, B over sine B, etc. So they're doing the exploring there as opposed to just being told, here's a rule, let's substitute and get an answer. So it's developing that deeper understanding, and you can ask them a lot of questions there. The last one here is a unit circle. Sorry, I'm just going to change it to handheld view. Okay, so it gives them the instructions, and in this one here, we've got here a graph application and a notes page. So when we go through to it, what they're able to do over the side here has been set up as what the angle is, what that is in radians, and the sine of the angle, and by clicking and dragging or changing the slider, we can make it bigger and we can see what is happening. Okay, we can ask them to focus on a particular quadrant. So I'll actually go up to quadrant 2. So if we're focusing on quadrant 2, we can see what the angles are in there. So it's the 145, and see what the sine of that angle is. As well as that, you can then get them to go back into quadrant 1 and notice that we can get the same angle there. Sorry, the angle there that has the same sine of the angle. So that's when you can start looking at, well, we've got quadrant 1. In quadrant 2, we can use 180 or pi minus the known angle and investigate further that way. Continuing on, and they've got the diagram here that shows that if we are at 50 degrees in the first quadrant, then what we're able to do here is 180 minus 50, and we're getting the same result, so sine of 50 and sine of 130. So these types of documents that are out there are absolutely amazing documents in terms of what the students can discover for themselves with that explore, and then lead to the conversations for the deeper understanding as such. This last one here, what you're able to do is change the angle, and the students are seeing the sine graph develop from the unit circle, and giving them information, as it says quadrant 4 is similar to the previous one, negative of quadrant 1, etc. So by being able to do these, sorry, my apologies, went to the wrong screen there, we're actually able to develop that understanding in students, and we can go back and assess it using Navigator, which is what I find is really powerful with Navigator, is just being able to send out those quick polls, being able to send out small documents and get information back that you can then provide to parents if you wish to. You can use it to have conversation with students as to how they're going, what they're understanding, what they're not understanding. So that's the gist of what I was going to look at. So I'm going to hand back over to John now.
Thanks, Mel. That was fantastic, and really nice to hear some of your experiences of using Navigator in the classroom. I think that it's always interesting when you have anybody talking about something, but when they're actually using it themselves and see the advantages, it's fantastic, isn't it? And I've used Navigator in my classroom, and I find it an absolute godsend, and so rich and rewarding for both myself and the students.
Yeah, I love using it. I have a lot of fun with it, and I'm seeing it, as I said, I used to do it in my grade 8 classes, and one particular class, just seeing them work with it is really powerful stuff. You can get a lot out of it.
Yeah, and I also like showing them the answers that they all give, and they can all comment about all the answers, and they can learn from each other's answers. Like you said, you can keep it anonymous, so anybody can say, you know, like that one you're talking about with the discriminant, why did the student give the answer of 1? And getting them all to reflect on why that may be the case. Whether they got that or not is sort of irrelevant. They can all think, oh, oh yeah, I can see why they'd have given that answer. It's not a silly answer. It's not sort of incorrect. It's incorrect for the question, but there's logic to what they're trying to say. So it's a very it sort of develops their learning so much more, and it's sort of self-generating, you know, because they've produced it all.
Yes, it's their data, it's their information, it's their knowledge, and have, as I said, I have a lot of fun with it.
So thank you very much for that. And I'd like to, again, just reiterate what you said about, and Ray mentioned it also, with the activities. I think sometimes we feel that we need to keep creating stuff, but there's plenty of activities for us to access. Here's the TI Australia website, which is what you were talking about. And if we go to teachers, then there's the Australian curriculum and the senior curriculum, as well as STEM and TI codes, where we can actually go to the Australian curriculum and we can access the different year levels and the resources that are already available for teachers to use. And I know that you both yourself, Mel and Ray, have used a lot, and so have I. You know, there's thousands of activities that we can access, isn't there?
Oh, yes.
Both on that side and also the American side. Fantastic.
Yes. Yeah. Thank you, Ray. Okay. Well, thank you very much, both of you. I certainly found it rewarding and learned a lot, as always. So thank you, Ray and Melissa, and I hope that people who are watching did too. We're going to begin wrapping things up now. So if you do have any last-minute questions, please try and get those asked. As I know, Melissa and Ray will endeavour to answer them or add them to future planning of webinars. And when you do leave the webinar tonight, a brief survey will automatically appear here in your browser. And your feedback does guide us as we plan future online events. We do listen to your feedback, so we hope you share your thoughts in a post-webinar survey. And importantly, your certificates of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and the YouTube versions of this recording, and as well as the relevant documents, both that Ray mentioned in his first half, and also Melissa's part where she was talking about the volume and the Sine Rule. Those will actually include as links as well. After you leave tonight, if you do need some post-webinar follow-up, please feel free to phone or email us, and we would love to hear from you. And sadly, that brings us to the end of tonight's webinar. Thank you so much, Melissa and Ray, for everything you've shared tonight. Really appreciate it.
You're most welcome.
Thanks, John. Thanks, Mel.
Thank you. Thank you both very much. And thanks, everyone, for joining us tonight. And we hope to see you back online soon. So good night all, and have a great night.
Good night.